Welcome back. We've been thinking about this function, and in the last video we took some values of x that were approaching 1 from the left, and we made this table. And we saw that as x approached 1 from the left, f of x approached -2. So remember, these arrows mean approaching, and this minus sign up here, that signifies that we're coming at 1 from the left, or from the negative direction. This is not the same as -1. X is actually approaching +1. It's just that x is coming from the negative direction. Okay? And as it does that, f of x is approaching -2. What you were supposed to do was the same thing, just on the other side. So you should have picked out some values and made a table. Now, you didn't have to choose these particular values, but you should have chosen some similar looking ones and gotten a similar looking table. And what we see from the table is that as x approaches 1 from the right, f of x approaches 2. +2, not -2. So we've got something different going on the right side of 1 versus the left side of 1. Pretty cool. Let's see what this looks like on the graph of f. All of these data points that we have will help us get started. For instance, on the right here, we've got f of 2 equals 2.24. So the point 2, 2.24 is on the graph. And we can do the same thing with these other 3 points that are on the right, and they'll look like this. Now it seems reasonable to assume that the graph of f is going to behave pretty smoothly in between these 4 points. So we can just draw it like this. And once we've done that, then we can look and see what happens as x approaches 1 from the right. What's happening to f of x? And what's happening to these y values? Well, like we said, they're approaching the level y equals 2. What happens exactly at x equals 1? Well, remember that f of 1 isn't defined. We would have had a 0 denominator, which means that there is no point on the graph where the x-coordinate is 1. So we're going to put this open circle here to remind us that this point 1, 2 is not actually on the graph. But that's okay. If we're just talking about x approaching 1, that means we only care about values of x that are near 1, not equal to 1. We can do the same thing on the left. Our table of values gives us these 4 points, and if we interpolate and assume the graph is smooth in between those points, then we've got this. And as we come in towards 1 from the left with our x values, then our y values are approaching y equals -2. And again, we'll have this open circle to remind us that there is no point at x equals 1 on the graph. Okay, let me make some space here, and we want to give an official name for this phenomenon of a function's value approaching something. We're going to call this a limit. So on the right here, we're going to say that the limit of f of x as x approaches 1 from the right is 2. And the notation for this is as follows. Limit of f of x as x approaches 1 from the right is 2. This is often called the right-sided limit, or the right-hand limit, at the point x equals 1. And we have a similar thing on the left. We can write the limit of f of x as x approaches 1 from the left equals -2. And there we have it. We've got our left-hand limit, and we've got our right-hand limit. We have the notation, we have the meaning, and we know what it looks like in pictures. So this is our left-handed limit, and here's our right-handed limit. So that's our first function. Kind of an interesting little function, isn't it? We have a couple short questions for you, and then we have a few more functions for you to play around with left and right-hand limits. And maybe those will be even more interesting. So why don't you go and find out?